Continuing on with our transformations, today we're going to be talking about rotation. We've done translation and we've done reflection, and now we are doing rotation. A rotation is a transformation that turns a figure about a point or a line. Basically, rotation means to spin a shape. The point a figure turns around is called its center of rotation. You just want to remember that so far, everything we've done, the shape has stayed the exact same shape. We're moving it in some way. Translating is to just slide it up and down or left and right. Reflection is to flip it over. And rotation is to spin it. But the shape itself stays exactly the same shape. We're just moving it. The center of rotation can be on or outside of the shape. It just depends on how you're spinning it. So what does a rotation look like? Rotation means to turn it. So if we take this triangle, and this is the center of rotation, we want to spin it around this point, it would spin like that. That would be rotation. And stopping it anywhere along that path would be some form of a rotation. This is another way a rotation may look. Let's say the point is not on the shape. Think about the Earth revolving around the sun. The sun is not on the Earth, thankfully, so it rotates around it. There's our center of rotation. It is rotated around that point, so it goes around and around and around, and that was our center of rotation. So rotating is to spin around a point. So if a shape spins 360 degrees, how far does it spin? All the way around. 360 degrees is a complete circle. Generally, if something rotates 360 degrees, it's back where it started. And that is called one full turn. If you do a 360, you're back where you started. If a shape spins 180, how far does it spin? So 180 degrees is halfway. So you've kind of turned around to face the other direction. So this is called a half turn. Rotating a shape 180 degrees turns the shape upside down, or to another side, depending on where you started from. So if a shape spins 90 degrees, how far does it spin? Well, that's only 1/4 of the way. Think about turning onto a road. Usually roads meet at 90-degree angles, and so if you make a right turn, you've turned 90 degrees. It's a quarter turn, or 1/4 turn. So, looking at this particular picture, describe how triangle A was transformed to make triangle B. Was it a translation? Did it slide? Nope. It rotated 90 degrees. And it did rotate to the right, because notice its point here, instead of being at the top, is now over here on the right side. So it went 90 degrees to the right instead of 90 degrees to the left. But it was a quarter turn. Now, how was this arrow transformed? So it was facing up, and here's a point in the middle, and now it's coming down, and it's over here, and it's facing down. That's 180 degrees. So it turned around to face the other direction. That's a half turn. When some shapes are rotated, they create a special situation called rotational symmetry. Now, just like yesterday, reflectional symmetry was when it was reflected, it was the exact same shape. Rotational symmetry is when it's rotated, it's exactly the same. It ends up looking exactly the same. So rotational is to spin a shape, and symmetry is exactly the same. A shape has rotational symmetry if, after you rotate it less than one full term, it is the same as the original shape. Because we know if we do a 360, we're back where we started. It's the exact same situation. But if I can rotate less than 360 and end up back exactly where I started, then I have some type of rotational symmetry. So here's an example. We have a square, and we want to rotate it around this point at the center. All right? I can rotate it 360 degrees, and I know it's going to end up looking exactly as it did before. All right? But it was also the same at 90 degrees. See, that was just a quarter turn, and it ended up looking exactly the same. So this shape is said to have rotational symmetry. A shape has rotational symmetry if after you rotate it less than one full term, it is the same as the original shape. Here's another example. So again, if I rotate anything 360, it always ends up being the exact same all the way around. It looks exactly like it did when it started. But when this one is rotated halfway, 180 degrees, boom, it looks exactly as it did when it started. So that means that it has rotational symmetry. Now, at this example, 360, anything you rotate 360 degrees is always going to look exactly the same. But there was nowhere along that route where it lined up. 90 degrees didn't work, 180 degrees didn't work, only 360 worked. Well, 360 works for everything because you're back where you started. So that means it does not have rotational symmetry. So does this shape have rotational symmetry? Well, let's try spinning it and see. So spin it. Oh, I think I see a couple of places there where it lines up. It definitely lined up at 360, but I also think that about 1/3 of the way, boom, right there it lined up. That was 120 degrees. Now, you may ask, Ms. Parker, how do you know it was 120 degrees? Well, it's 360 to get all the way around. And this one has 3 points where it lines up. So at this point, and at this point, and at this point, it lines up to be the same shape. So I took 360 and divided it into 3 equal chunks, and that's how I know that it was 120 degrees. Now, just like all the other things that we've done it on the coordinate plane, which means that there's some kind of rule with the points to help us to find where it's going to end up. Now, when we talk about rotations on the coordinate plane, we're always rotating around the origin at 0, 0. Now, you can rotate around other points on the coordinate plane, but we don't have any rules for that right now. We just have rules for when we are rotating around the origin. And so we have rules for rotating 90 degrees, and we have rules for rotating 180 degrees. But it's extremely important to note what direction are we rotating around the origin. In general, when we're on the coordinate plane, we always want to rotate counterclockwise. That's going in this direction. That is the way that we generally deal with things on the coordinate plane. That's why this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, because that's the order that we go around the coordinate plane in. So if I'm going to make a 90-degree rotation, that's going to be counterclockwise. So that's going to rotate something over into this neck of the woods. That is going to be a simple rule. All of these rules are simple. We're not adding and subtracting a lot, but you do have to memorize what that rule is. The rule for a 90-degree counterclockwise rotation is to switch X and Y. So I switch X and Y, and then I have to change Y's sign. So switch and change Y. That's the rule for a 90-degree rotation. For 180 degrees, we're coming all the way over here. That's the halfway point. So for 180 degrees, actually we don't switch anything. Everything stays where it is. We just change signs. Both of them. We change both signs. And then we have 270 degrees. So that's 3/4 of the way around. And for 3/4 of the way around, we're back to switching again. So we're going to switch. But this time, we're going to change X's sign. So 90 degrees, switch and change Y. 180 degrees, just change the signs. And for 270 degrees, we switch and change X. It's also important to note that 270 degrees, if I go 3/4 of the way around counterclockwise, that's going to be the same thing as if I went 90 degrees clockwise. So what you want to remember is that these are the rules for counterclockwise, but if we're rotating clockwise, it's going to be the same rules, just in the opposite order. So when I'm going counterclockwise, 90 is switch and change Y, but if I'm going clockwise, 90 is switch and change X. It's the same rules, just in the opposite order.